And for our final talk of the day, folks, we're going to bring in Doug Schmidt. Doug Schmidt is a former Chief Technology Officer for the SEI. Douglas Schmidt is now an SEI visiting scientist. He guides the SEI blog that reports on new developments, software engineering research. He is also a tenured professor and associate chair of the Department of Electrical Engineering and Computer Science at Vanderbilt University. And Doug is joining us from Washington, D.C. today. Doug, take it away.
Great. Thanks very much, Shane. So before I give my talk about applying agility to DoD Common Operating Platform Environment initiatives, I want to briefly recap how we've covered material earlier in the day. We started off with Ms. Terry Takai, who's the Chief Information Officer for the DoD, talking about how Agile methods are being used in DoD software acquisition and development environments. And Ms. Takai is also involved in a number of other efforts related to agility and applying Agile concepts to developing shared infrastructure, such as the Joint Information Environment. We then heard from Anita Carlton, who's the director of the SEI's Software Engineering Process Management Program, and she gave an overview introducing the concepts of agility that we're working on at the SEI, as well as the importance of being able to do R&D to enhance and validate agility at scale, which is really one of the key themes that pervades all the talks you heard today. Marianne Lapham, who's a senior researcher for the SEI's Acquisition Support Program, talked about some of the R&D that's taking place in her group on Agile methods, applying tools, techniques, and practices for the DoD, especially in some of the more advanced combat systems where the right answer delivered too late becomes the wrong answer, so you have to be able to apply these methods in a very mission-critical context. Ipek Oskaya, who's a senior researcher for the SEI's Research Technology and Systems Solution Program, talked about some of the work they're doing there and the research on managing of architectural technical debt, which are ways of trying to figure out how to refactor and rework the software using various tools and quantitative methods to figure out when to make the appropriate trade-offs between change and stability. And then you just heard James Over, who's the manager for the Team Software Process Initiative, talking about balancing agility and discipline. And we really appreciate everyone taking time today to talk about the work that they're doing and how this applies to the concept of Agile at scale. So the other talks discussed a variety of different issues, general topics that relate to the DoD. My talk is going to narrow down on a particular set of topics that I've been working on for the past 20 years or so, and these relate to what are called common operating platform environments. And we're going to talk about how agility is crucial to developing these kinds of environments. And I'll first start by motivating what the needs and challenges are for the DoD in this space. As you probably all know, or may be interested to learn, the DoD has a number of strategic goals for acquiring the systems that they are going to be using. More recently, with the accelerated tempo at which we're trying to deploy our forces and the expanded threat spectrum that they face, there's a real push to be able to deliver enhanced integrated warfighting capability at a lower cost over the life cycle and across the enterprise. We tend often to think about the acquisition phase as being development of these systems, but of course it's also important to recognize that these systems are going to be sustained for a long period of time. In fact, these days, with some of the push towards efficiencies, sustainment is becoming even more important because we're not recapitalizing the systems and building new ones. So it's very important to come up with strategies that are going to work throughout the life cycle. It's also important to be able to reduce the time needed to acquire and insert new technology in either new or legacy systems. These days, people are trying to figure out ways to make the systems more secure, and we often have to go back and update existing software, existing systems to work more securely in a very threat-rich environment. There's also efforts to try to leverage the large amount of computation resources that are on today's DoD platforms to do dynamic resource management, to be able to provide support for fault tolerance. And a lot of these techniques are still evolving and still transitioning down from the R&D community. And so finding ways to get these into the programs that either exist today, have existed for decades, or are in the middle of being planned is crucial, and doing this in a way that's as rapid and cost-effective as possible. And, of course, another key goal that undergirds everything we're trying to do in the DoD these days is the development of sustainable business and workforce strategies. Back when I was a grad student 25 years ago, the bulk of the work that was being done in high tech was done in the DoD. It was the driver of technology. The bulk of the people who were doing interesting projects in the U.S. in R&D and in the world of software development had DoD backgrounds. That shifted quite a bit in the last 3 decades, and increasingly we see the technology base moving towards the commercial world, and there's also a lot of expertise available outside of the U.S. So finding a way to alleviate the complexity of software is crucial to helping the DoD meet their acquisition goals. But there's some problems. It's pretty clear for those of us who've been working in this field for a long time that especially in the context of lower budgets and expanded threat spectrum, we're not going to be able to be very effective achieving our strategic acquisition goals if we have to support too many software development activities, each of which implements a unique solution. The diagram on this slide illustrates what often happens today where people develop systems in various domains and they build them from scratch using different stacks, many of which are done in an ad hoc, proprietary, and redundant way. These redundant stovepiped solutions are very expensive to develop, integrate, certify, and sustain. They're vulnerable to exploits because oftentimes they weren't built with the concept of network centricity and interconnectivity and systems of systems in mind. And moreover, because they're often built in such a stovepipe way, it's hard to share resources effectively, which means you often can't achieve the end-to-end quality of service that you'd like to do things like real-time common operating pictures or distributed weapons control. Even though you have the resources, they can't be harnessed and controlled in a concerted way in order to be able to solve the end-to-end requirements. And so these are some of the things that we wrestle with. One of the approaches people have come up with, and this goes back actually quite a ways, is to support the concept of a common operating platform environment. I've been involved in this type of an activity since I was a researcher on DARPA programs in the mid to late 90s, and when I went to DARPA, I was a program manager for many years working on developing technologies to support these common operating platform environments, or COOPs. And essentially, the goal of COOPs is to foster competition and innovation by improving the way in which systems are architected, making them more modular, loosely coupled, well-defined, so that you can provide applications that share many resources. And rather than building things in a stovepipe manner, as is shown on this slide, instead we can factor off many shared resources in the form of middleware and common operating systems and network protocols. And we'll talk a bit more about that shortly. Another goal of COOPs, as they're called, is to ensure full disclosure of design specifications to enable a competition, a marketplace for business in the DoD so that other integrators, smaller businesses, and so on can play in this space. And figuring out what the appropriate abstractions are, figuring out what the right level to document these design specifications is a crucially challenging issue. And many techniques such as patterns and model-based tools have come along to help facilitate this. Also important in COOP-like approaches are to be able to systematically reuse software design and implementation artifacts. This includes, of course, the implementations themselves, the code, but also the surrounding artifacts, the metadata, the documentation and so on, that's necessary to be able to share these and reuse them in a systematic way. Also important, naturally, it's not just enough to have reusable software. It's ideal to have reusable software that's based on common and portable standards. And those standards have implementations that are either available in commodity form or available in open source form often in order to be able to provide a marketplace for people to pick and choose and select the best-of-breed solutions. Interfaces alone, though, are not adequate enough. You also have to be able to find some way of being able to enable interoperability between the hardware and the software, between the different pieces, the different layers, the different modules, the different nodes in a system. And crucial to this endeavor, of course, are common protocols and common data models that make it possible to communicate and interact and send data back and forth in a way that's understandable, both syntactically and semantically. And yet another key theme of common platform environments that help to foster competition and innovation is to amortize the creation of conformance tests to make sure that people who provide solutions in this space actually do in fact interoperate, do in fact have portable interfaces, and be able to come up with ways of being able to automate the validation of unit testing and system integration testing to assure the crucial software and hardware and system quality attributes end-to-end. We've been trying to do this for a long time. There's been some success. When people have been successful, there have been quite a number of benefits. One of the most obvious of which is that rather than having to reinvent and redevelop the applications and all these layers of software each time on each program, we can leverage commonality at multiple layers in the system. Of course, we already know we are leveraging quite a bit of the hardware, and we're leveraging quite a bit of the operating systems and protocols like TCP/IP, but it's also the case that we want to be able to leverage commonality at middleware layers as well. Some of these layers are domain independent, things like the host infrastructure middleware, which encapsulates the underlying operating systems to be able to make it possible to write code that's more portable across different operating systems and virtual machines. Things like real-time Java are relevant here. Distribution middleware, which makes it possible to make distributed programming calls look like standalone invocations on components or services or objects. SOAP, DDS, Corba are examples of this type of domain-independent commonality. Common middleware services, which build on top of the distribution middleware to provide higher-level domain-independent services that handle things like notifications, security, scheduling, load balancing, streaming of data, and so on. Most of these things these days have become commoditized as a result of a lot of R&D activities that have taken place over the last couple of decades. In the space of the integrator, the things that are provided by value-added OEMs and other integrators in the DoD space, there's domain-specific services, which are really tailored to the requirements of particular warfighting domains, such as C4ISR systems, anti-submarine systems, land attack, mission computing, air defense, and so on. Being able to build on an infrastructure that provides systematic reuse, of course, is crucial to being able to reduce acquisition and new technology and social cycle time by being able to take existing infrastructure and customizing it by programming at the variabilities in a product line architecture or a framework to be able to produce and ship the code more rapidly, getting it to the field to the warfighter. And, of course, another benefit of having COOPs is it allows us to be able to have sustainable workforce strategies. The government is not in the position at the moment, and perhaps in the future, to be able to reinvent and rediscover all these core capabilities in these stylized vertical stovepipes repeatedly. And so having strategies for effective contracting, having strategies for effective management of data rights and licensing models is crucial to be able to take the limited workforce we have and amplify their productivity by not reinventing the wheel each time. Well, this is all well and good, but what I want to talk about in the rest of my talk is what's taken so long to realize the promise of these common operating platform environments, and how can agility help us? So despite the fact that we've had substantial technical advances in the past decade or so, based on lots of R&D and lots of advances in the commercial world, developing affordable and dependable COOP-based solutions remains elusive, and there's a number of reasons for this. One of the reasons for this is that when people try to build common platforms, they often tend to spend a lot of time trying to build the infrastructure. And this leads to something called the serialized phasing problem, where people spend so much time trying to build the infrastructure that it may take years, probably hundreds of person years, to develop this infrastructure. And meanwhile, the application developers are sitting around twiddling their thumbs, not sure exactly what the characteristics of the infrastructure are going to be. And as a result, by the time they get around to building the applications, they discover that the infrastructure was perhaps built improperly, and so it doesn't provide the appropriate quality of service or functionality. And you don't discover this until very late in the life cycle, typically during system integration time. Other problems that we run into are with common operating environments is that the time it takes to get projects under contract tends to take a very long time in traditional contracting models. And when you're trying to build common infrastructure, if it takes a long time to get the work on contract, people won't have a chance to develop the infrastructure, and the applications will be even further delayed due to the serialized phasing that's taking place here. Yet another problem is that many contracting models assume that common operating platform environment requirements can be defined fully up front. And that means that when these requirements inevitably change, as they will because they'll be used in different environments, they'll be used for different requirement sets, it costs quite a bit in order to be able to have the change orders in place to make the modifications. The slide here, the picture shows a somewhat humorous picture where we have a small dinghy with the words original contract on it and a much larger yacht with the words change order, reflecting the fact that if we don't get the contracting models done well, then the changes are going to be very expensive for the government. Another big problem that we run into in common off-the-shelf environments is that the use of COTS products, which are very good in the commercial world, are often not suited for certain types of mission-critical DoD combat systems. And so we take things that work very well when they're applied to systems that can have 95% availability, and if things don't work, if you drop a call or if the web page doesn't refresh, you simply wait a few minutes and try it again, and everything's fine. In a mission-critical environment, where the right answer delivered too late becomes the wrong answer, some of these technologies are simply too big or too slow or not dependable enough to be used reliably. And if you build your infrastructure on top of these, then your applications are almost guaranteed not to be able to provide the end-to-end performance that's expected of them in those types of critical contexts. Another challenge I've seen take place many times over the last decades or so is overly adhering to standards and reference architectures at the common operating platform environment level that made sense a decade or so ago but have failed to keep pace with the way that technology changes. The DoD is one of those environments where you have to be able to take a long-term perspective. And some of the things that take place in the commercial world where technology refreshes every couple of years are not appropriate for the DoD. But by the same token, we need to be able to integrate new technologies. We need to be able to take advantage of new hardware, new software, new platforms, new devices. And we also need to be able to come up with software architectures that are more flexible and resilient than simply adhering to a particular standard that may go out of date. So the crucial issue here is not to not use standards, it's to come up with architectures and use standards that themselves are capable of being refreshed and applied anew over long periods of time. At the heart of these problems that we just talked about is really a lack of a holistic approach that balances key business, managerial, and technical drivers at scale. And so in the last part of my talk, I just want to talk about some of the key success drivers for Common Operating Platform Environment initiatives and the way in which agility helps to address those drivers and make them more effective. First perspective we have here on this slide is the point that doing a good job of a COOP infrastructure really requires a balanced view. It requires a business sense of being able to make sure you pick the right economic model and the right way of doing contracting and data rights and licensing. It requires understanding of management, to have the right leadership and guidance, to do the lifecycle management and the methods properly, to be able to understand the strategic role of software, to have strong S&T connections to reduce risk. And of course, there's the technical drivers. This is the fun stuff from my perspective, from an engineering perspective. What are the foundations of actually building the technologies to make it possible to make these COOPs work at scale? If you take a look at agility, there's a number of ways that agility can be applied to help address some of the management drivers. Obviously, if you try to build a common infrastructure and you don't have close interactive feedback loops between the people doing the applications and the systems engineers and the people, the software engineers and the developers doing the infrastructure, you're going to quickly develop a lot of reusable artifacts that aren't actually very useful and are simply there to take up space but not be applied in a systematic way. So there's a real need for an agile approach to cooperating closely between the users, developers, testers, and even the certifiers to be able to deliver these COOP capabilities and avoid integration surprises without these long serialized phasing life cycles that are very fragile and tend to break at unexpected times late in the life cycle. One of the things we've observed over the years is being able to roll out incremental delivery every 4 to 8 months or so that the people who are developing the applications get in a battle rhythm of knowing when to upgrade and knowing when to leverage what's there. So it's much tighter spirals, which is something that Agile does a good job of from a management point of view. There's obviously a need for agility in the contracting side of the world, coming up with ways of being able to get work and work orders on contract quickly using things like indefinite delivery, indefinite quantity contract vehicles, being able to issue task and delivery orders for each release, and being able to make sure that the people who are building the systems and the people who are doing the acquisition are in sync about the priorities to make sure that the contracting supports the needs and considerations. From an architecture point of view, agility is crucially important here. There's a need, of course, to be able to develop architectures that are change tolerant. Inevitably, the standards will evolve. The hardware will get better. The software will change. The languages, the operating systems, the middleware will all evolve over time. And coming up with ways of future-proofing the architecture and then being able to use technologies and techniques and methods like the technical debt work that Ipek Oskaya talked about is very important to be able to make decisions about when to refactor, when to re-engineer based on empirical data and evidence rather than relying on legacy commitments which become obsolete and ossified over time. It's also important to be able to pick COPS technologies that have the appropriate quality of service capabilities for the way in which they're being used in a particular mission. Some things that are off the shelf and standards-based work well in mission-critical environments. Others don't. The choice of which ones to choose should be driven as much as possible through trade studies, empirical analyses, and various types of quantitative analysis as opposed to simply looking at what sounds like the latest fad that's coming out from Madison Avenue or Wall Street to tell you what to go for. This next slide just summarizes, and I'm not going to talk through this in detail, just summarizes the various ways in which challenges involved in trying to develop common operating platform environments can it be resolved by the application of agility and agile methods, agile techniques, agile tools. And in our own work developing middleware for the past 2 decades, we found it crucially important to take an agile perspective for all aspects of the work, business, management, and technology. So to wrap up, the DoD initiatives for common operating platform environments need to be viewed in a holistic way. I firmly believe that one reason why we've not succeeded much in the past is we haven't taken a holistic view towards how these systems are built. These days, this is being radically challenged by some of the efficiency issues we're wrestling with, by some of the cybersecurity issues we're wrestling with, and by the need to be able to deploy software and new technology to the field rapidly. And simply building everything in stovepipe ways in a layered manner that is brittle and proprietary and stovepiped is not an effective way to move forward. Developing COOPs is achievable and valuable, but it's not easy, and agility is crucial in these different dimensions, but of course it's no panacea, and we still have work to do to be able to come up with the appropriate methods and tools and techniques that will work in an agile way at scale, which is one of the themes that you heard about throughout the webinar today. And then finally, we really need your help. This is not something that can be done by any one group, any one institute, any one contractor, any one government program. We need to bring together people from academia and the R&D labs to do the appropriate S&T to reduce the risks, bring in industry to help develop the workforce, figure out what the requirements are, and of course the government needs to be there to figure out how to do the governance and the appropriate acquisition processes to keep track of it all. So with that, I wrap up and welcome any questions.
Okay, great, Doug. I was just going to ask, hope you're ready for some questions. I know we didn't get a chance to discuss that, but we got some questions for you, so I'll start rattling them off if you're ready. Okay, first one from Jonathan asking, does the upcoming DoD Joint Information Environment qualify as a COOP from your point of view?
I would say that the Joint Information Environment, or the G, is a COOP, although it's really more of a framework for thinking about how to acquire and how to deploy common infrastructure. So I have a feeling it's more going to be a set of guidelines and policy directives for how to move towards a common set of things as opposed to a very specific and strongly or closely defined set of standards. I think it's going to be more of a policy approach than it will be a set of standards, although obviously the policy approaches will leverage and help to motivate the application and development and adoption of said standards and common operating pieces.
Okay, great. Next question from Mary Ann asking, programs are resourced by Congress through program elements. This paradigm seems to reinforce stovepipe architectures. How do you recommend DoD overcomes this money impediment to implementing and resourcing a common operating environment / shared platform?
That's an excellent question. That's been one of the main impediments. People typically, one of my great experiences in life is people tend to do what they're reinforced to do. And if they're reinforced to develop vertically integrated stovepipe systems, that's exactly what they'll do. I think that there have been a number of efforts of late gaining quite a bit of traction in the last couple of years that are helping to address this. There's work that the Navy's doing on open systems architecture. There's work that the Army's doing on common operating environments. There's a joint Army-Navy program called the Future Airborne Capability Environment, FACE. And these are all essentially, you can think of them as the movement towards horizontally acquired systems. So in the FACE initiative, for example, which I've been doing some work in, it's developed as a common operating platform environment. That's the way it's funded. That's the way it's managed. There's reinforcement for people to play in that space. There's a consortium that's run by the Open Group that has managed activities between the government and industry contractors, and people are incented for doing the right things. And there's similar activities going on, again, in other services, the Air Force as well. And so this is something that will not happen by itself, and it's going to require a tremendous amount of buy-in and oversight and adoption by Congress and by other government and regulatory groups. But that's why I was emphasizing earlier this notion for a holistic strategy. It's not just about the technology. It's not just about the management. It's not just about the business context. It's about all those things working together. And historically, we haven't had those things working together. We haven't even realized they needed to work together sometimes. But if we get them to work together, our likelihood of succeeding goes up quite a bit.
Okay, excellent. Next question from Tom, asking, one of the challenges in using Agile techniques on projects for DoD systems is that the evaluation process requires clean, crisp documentation. How should this be handled considering Agile values software and people over documentation?
That's a great question. I wouldn't say necessarily that Agile doesn't value documentation. I think Agile values documentation that is based on something that's actual, as opposed to spending lots of time developing artifacts and documentation in the abstract, abstracted from real things. Agile is much more about trying to co-evolve the documentation, auto-generating documentation, auto-generating descriptions, Java doc, Doxygen type of things that describe what's actually there, and then supplementing those with the appropriate architectural documentation that may be more difficult to reverse engineer from the code. I think the crucial issue there, though, that's at the heart of that question is how do we know that people who are claiming to do Agile are actually following the practices properly and not simply hacking stuff up and taking lots of shortcuts that are going to tie the government and get them in a world of hurt down the road. And in that sense, some of the work we talked about earlier about agility and discipline and balancing those things is crucial, and the ability to be able to give honest assessments of proper Agile practices, especially at scale Agile practices, is crucial, and it still is, in some sense, is work that remains to be done. There's R&D that remains in that space that we're working on.
Okay, excellent. Also, Doug, we're getting a number of requests about getting a copy of your slides. We did not put them in the Resource Center with the other ones, so if you want to make them available, if that's okay with you, we can send out a PDF.
Yes, that's not a problem at all. I should also mention briefly that the material I described here, at least in part, as well as some of the material that the other presenters have presented today, can be found at the SEI blog at blog.sei.cmu.edu. And that's a good resource. We should probably also make sure there's a link somewhere for people who want to follow that, because a lot of this material that you'll see in the presentations have been covered in the blog as well.
Excellent. We do have a link to the blog and those various postings. They'll come out in a follow-up email. Probably go out tomorrow, folks, tomorrow or Thursday. That'll lead you to a landing page with all the resources we talked about today, the blog post that Doug's mentioned. We'll also make sure Doug's slides are available to anybody that wants them. We're at 4:05. How about one more question, Doug? I know we're a little over. If it's okay with you, we'll do one more.
That sounds great.
Okay. Again, from Marianne asking, any examples or benchmarks of successful COOP initiatives within the government and within the DoD in particular?
Yeah, there's a number of them. I think one of the ones I just mentioned was the Future Airborne Capability Environment, or FACE, which is a joint Navy-Army project. And one of the things that they've done a really nice job of is coming up with a holistic strategy that addresses many of the things that I have here on this last slide quite nicely. They've thought this stuff through. If you Google FACE or Future Airborne Capability Environment, you'll find a web page that's hosted by the Open Group that talks about their process, talks about their methods, talks about the use of science and technology to reduce risks, to do automated conformance tests, and so on. And that's one of the very recent examples that I'm familiar with that has done a real nice job, and hopefully will become a paradigm for future success by other groups that can likewise adopt a balanced perspective.
Doug, thank you very much for your presentation. We thank you for your time.
Thank you very much.
Folks, that concludes the SEI Agile Research Forum, meeting the challenges of large-scale systems. We appreciate you spending 3 hours with us today. You know your time is very valuable. If you have any questions or comments from the day, you can always send anything to info@sei.cmu.edu, and we look forward to hosting you at future events.